I wanted to just do a little bit of a follow-up video here to cover off this LHT00SU1 as a signal generator. Now in part 1 in the first video we discovered how we needed to set up the USB ports so we could have a USB AX port and a pulse view port, and that's critical because we need to use the USB AX software to be able to create our signal generation. And what I've got so far is I've set up this, so we've got the USB AX here, and I've just got on channel 1 I've got a 500 kilohertz clock being pulsed out, and it's constantly triggering an endless loop. And on my board, just for comparison, if I just close that off there, we've got a Teensy, a 4.0 Teensy, and that again is set to do a 500 kilohertz signal. And I'm actually pretty impressed with this. It's a little bit slower on the fall and rise time, we'll have a look, than the Teensy, but the signal is cleaner. So I'm going to just put this here, and hopefully we can see that. See if I can focus it a little bit better, like that for you guys. So this is the signal generator, the cheapo signal generator. If I can just get that on there, of course, very difficult to get in. There you go. So that's the signal generator signal. And if I just turn, I will just see if I can drop that on there like that. Okay, that's a better pin. Right, okay. So I'm back. Okay, so that's, let me turn the light out. Is that better? Okay. So that looks okay. So if you notice the raise and fall times here, that mean voltage looks a little low. Let me do that again. That's better. Right, okay, so hopefully you can see that, guys. And in particular, we're looking at these mean results here. Take notice of the volts, 4 volts peak to peak, and take a note of the raise and fall times. So you've got 6.49 nanoseconds, 5.87 fall time, nanoseconds again. So that's not bad. Also take note of how clean the signal is up here. And if I just zoom in a little bit, got nice clean, not much bounce as it goes up and down. And let me just move that onto the Teensy, just over here, if I can see with the light out, that is. Okay, so this is the Teensy. We clear those stats again. Okay, and if we just zoom in a little bit here, we can see that we've got quite a bit of bounce on the Teensy, to be fair. And also notice the voltage, more 5 volt really, and climbing significantly. And then we've got but it is a much faster rise and fall time on the Teensy. But it just the signal overall just doesn't look as clean as it would on the signal generator. And I'll just put the lights back on, so watch your eyes. So just to recap what we've got there. So this is the Teensy. Now this is on that probe there. That is the signal on there. And if we just flick that back so you can see what I'm doing, put this on here like that, and then if I can grab it a different way, like that. And now it's on the analog pin. Sorry, not the analog pin, the digital pin, pin 1, and that is the signal there for the analyzer, for the signal generator. Sorry. So quite a clean signal. The exciting part about this, and this is why I'm going to keep this video brief because I want to get onto the next bit, is it looks like here that we can, it looks like here that we can load in a waveform file. And I was reading in the manual with this USB software that you can actually capture the signals, and I'm thinking about my CAN bus project now, because this the maximum frequency of this unit is 500 kilohertz, which is the high-speed bus on CAN bus on my car, and the medium speed is 125k. So theoretically, I could record a CAN bus signal and keep playing it back onto my development circuit. Is that possible? Well, it's going to have to be tried. So I hope that was useful. I actually like this. I'm getting more and more into this, and I'm thinking that I just would like to see what the oscilloscope usefulness is, and versus the bench oscilloscope, which could be interesting to see, you know, where the limitations lie there. So if you're just sort of tinkering in the shed sort of thing like I do, you know, tinker of everything and master of none, then, you know, would this do? Would this £40 device do? Well, let's see. Okay guys, I hope you found that useful. If you want to see more videos about this, especially around this little black box, like and subscribe, guys. It lets me know that that when you watch this video and I get likes and views, then it lets me know that you want to see more, especially around, you know, is it worth my while connecting it up, you know, so when I'm doing oscilloscope type tests to see whether it would function. You know, if you're just sort of tinkering in the shed, is it good enough for that sort of thing, you know, for a £40 scope? Or do you really need a bench one? Sadly, I haven't got anything in between that. It would be great to have something, you know, sort of around the 200 sub 200 quid mark to test. The Siglent, the one I'm using here, was 450 quid, so that's, you know, probably on the expensive side for tinkering, to be fair. Bit of indulgence for myself, to be fair. So, but anyway, like, subscribe. Let me know you want to see more. Really appreciate it, guys. You guys take care, and I'll see you on the next one. Take care.